Alright, so in the first half of 14.1, we're just going to be looking at basic trig identities. A trigonometric identity is a trig equation that is true for all values of the variable for which all expressions in the equation are defined. So as we move through this, there's like 8 basic identities, which we're going to write down in a second. These are going to kind of be your home base, and you're going to use them to kind of go through a lot of these problems in this unit. So our basic identities include the cosecant of theta, which you want to think of as the opposite of sine. So before, we're kind of familiar with sine, cosine, tangent. We're just kind of building on these. So cosecant is the opposite of sine. So I could also look at that. Sine of theta is the same thing as saying 1 over the cosecant of theta. Secant is the reciprocal of cosine. And then I could rewrite that the other way. Cosine is 1 over the secant of theta. And then finally, cotangent is the reciprocal of tangent. So cotangent of theta equals 1 over tangent of theta. Reverse that, tangent of theta is 1 over cotangent of theta. So again, how you want to look at these is we're kind of just adding onto sine, cosine, and tangent. We're building on these values or these ratios. Another way that we can write tangent and cotangent, which is going to be helpful when we're simplifying today, is I could also write tangent of theta as sine over cosine. Why can I do that? Let's go over. So, as we know, we have SOHCAHTOA. We learned this in geometry. Tangent, TOA, TOA, tangent is opposite over adjacent. So I'm saying that tangent is also the same thing as saying sine over cosine. So let's expand that and see how that works. And this is like the first trigonometric identity that we're going to do here. So I have written down tangent equals sine over cosine, and I want to prove that that's the same thing as opposite over adjacent. I can rewrite sine as opposite over hypotenuse and cosine as adjacent over hypotenuse. And from there, what we learned in our last chapter is that if two fractions is the same denominator, I can just get rid of it. So I'm going to cancel out those hypotenuse denominators, and I'm left with tangent equals opposite over adjacent. So I can see that tangent equals sine over cosine is an equivalent expression. With that, cotangent is the reciprocal of tangent, so if tangent is sine over cosine, then cotangent is cosine over sine. So as we're moving through this unit, you definitely should write these down. Have these in front of you when you're taking any quiz or doing any practice problem. These are going to be what you want to refer to as you're moving through these newer types of problems. So all we're going to do here today is identify identities. So these questions are going to seem a little bit different, and you're going to see in a second. We're going to run through 3 examples and go from there. In the first example, I want to show that the sine of theta times secant of theta is equal to the tangent of theta. So I'm looking at what I have on the left, and I want to prove that it matches up to what I have on the right. So right now, the left and right side of that equation don't look equivalent, but if I rewrite everything using these basic identities, that's my goal. So I'm going to rewrite stuff using these 8 identities that I see here, and I'm going to see if I can get the left and right side to match up. So what I'm going to do, usually whenever you see secant, cosecant, I'm going to try to rewrite these in terms of sine and cosine. Secant matches up with cosine, so I'm going to rewrite this as sine of theta times 1 over cosine of theta equals tangent of theta. From there, now I see sine and cosine on the left side, so I'm going to rewrite tangent as sine and cosine on the right side. From here, I can see that most everything matches up. To get the right side to match up with the left side, I'm going to rewrite sine over cosine as sine times 1 over cosine of theta. Now, I can cancel out those cosines on both sides, and I can see here I have sine of theta equals sine of theta. Now, basically, I've simplified to the point where my left and right side match up, and that's my goal. That's what I'm trying to do. In example B, we're going to do this, but in a different way. Here, I want to show that the cotangent of theta is equal to the cosine of theta times the cosine of theta. So again, I want to keep rewriting my left and right side until I can get them to match up. So again, whenever I see tangent or cotangent or cosecant, I'm going to try to write these in terms of sine and cosine. So first, I'm going to write cotangent of theta as cosine over sine. Cosecant matches up with sine, so I'm going to rewrite this as 1 over sine theta times cosine of theta. Now from here, instead of expanding my expressions, I can also do this in a different way. So my left side's good to go. On the right side, 1 over sine times cosine, I can just kind of mush into one fraction as cosine over sine. And again, my goal is that showing the left and right side match up, which I have done. So you can see in A and B, in A, I expanded the equations and kept simplifying stuff. Here, I could just get the fractions to match up. As long as they look the same, that's your goal here. So here, I'm good to go. I don't necessarily have to cancel anything out. One more example, and we'll be good to go. Here, I want to show that tangent of theta times cotangent of theta equals 1. So, as I said before, whenever I see tangent or cotangent, typically a good rule of thumb is to rewrite these in terms of sine and cosine. So I know that tangent is sine over cosine, cotangent is cosine over sine, and I'm going to leave the right side the same. Now from here, what we kind of went over in the last chapter is when I'm multiplying fractions, if I see something on the top and bottom, they're going to cancel each other out. I see there's a cosine on the top and bottom that cancel. I also see that there's a sine on the top and bottom that cancel. Everything here cancels, leaving me with 1 equals 1. And I'm done.